Today I am going to prove that the reciprocal of the total resistance, that is, this is the total resistance R. The reciprocal of the total resistance is equal to sum of the reciprocal of individual resistance. 1 by R1 plus 1 by R2 plus 1 by R3 and so on, in parallel combination of resistor. When resistors are connected in parallel like this, when resistors are connected in parallel this way, I am showing three resistors connected in parallel. When resistors are connected in this way parallel, then the total resistance R is found to be reciprocal of the R is found to be the sum of the reciprocal of each resistance. This resistance is R1, its resistance is R2 and is R3. Now how can we prove this? We can prove this way. Look at this. Current is, let's say, I. Current is I. I is passed through one of the end and it divides among the three resistor. And let's say current in first resistor is I1, first branch, I2 in second branch, and third branch it is I3. Current divides among them. Practically it is found that current divides among them. And we can write all these in the form of explanation. We can write this way. Let the resistance of resistors, let the resistance, or we can say let the resistors having resistance R1, R2, R3, etc. are connected in parallel, and current I is passed through them. What arrangement is made, everything is written here. Now next step, what can we say? Now when we measure the current in each of the branch and we measure the potential difference in each branch, what is found? We can write this practically. The current, the sum of the current flowing through each resistor is equal to the total current very simple. This I is equal to I1 plus I2 plus I3. We can write this also. I is equal to, it means I equal to I1 plus I2 plus I3 and so on. This is, let's say, equation number 1. Now another observation was also there, and that observation was about the potential difference. PD across each resistor is found to be equal to the total potential difference. Total potential, what it mean? The potential difference between these 2 points, let's say this point to this point is if B, then potential difference across first branch is also B, second branch also B, third branch also B. That's why PD is not unequal. PD across each of them is found to be equal. Now we are going to use the mathematical calculation, I mean to say derivation. According to Ohm's law, we can say that according to Ohm's law, what is found? Ohm's law says that V equal to IR. V is equal to IR. Total PD is equal to total current into total resistance. V equal to IR. And if it is so, then I equal to V by R. And let's say this is equation number 2. In the same way, if V equal to IR, then in first branch, Ohm's law acts like this. Potential difference is same V, but current is I1 and resistance is R1. That's why in first branch, V equal to I1 R1. And in this case, I1 is equal to V by R1. This is equation number 3, let's say. In the same way, in second branch, V equal to I2 R2. If it is so, then I2 is equal to V by R2. And this is equation number 4. And in third branch, potential difference same B, and this is equal to V equal to IR. That's why I3 R3, or we can say I3 is equal to V by R3. And this is equation number 5. What I am planning, actually I want to substitute this value in this equation first. Yeah, I want to substitute this, the value of I1, I2, I3 and I in this equation. That's why substituting the value of what? Value of I1, I2, I3, etc. from equation 2, 3, 4, 5, etc. maybe other also, etc. from in equation 1. What we get? We are going to substitute this in this equation. Then what we get? This is very simple. We get this. In place of I am writing what? V by R, V by R. And in place of I1, V by R, R1. In place of I2, V by I2, R2. And in place of this I3, V by R3. And so on. And next step, you can say V by R is equal to, if V is taken as common, then we'll get 1 by R1 plus 1 by R2 plus 1 by R3 and so on. And V cancel. Therefore, 1 by R, reciprocal of the total resistance, is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. That's why we proved the equation. What was asked at first, this we had to prove this. And what is our conclusion? If resistors are connected in parallel, then all of them get same voltage, but current divides among the resistor, and the resistance of the resistor can be calculated by using this equation. Total resistance, reciprocal of the total resistance, is equal to sum of the reciprocal of the individual resistance. Okay, this much for today.